Okay, so question 2, we've got to express this in the form r sine theta minus alpha. So notice this time we've got a minus here, okay? But there's a minus in here because we've got a minus in our sort of expression here, right? So that's why it's got to be with sine. It's got to be consistent, okay? And the other thing to remember with these harmonic equations, yeah, whatever we start with, if we start with a sine, you're going to get r sine here, okay? We'll see in the next question that it starts with a cos, so then we're going to have a cos here. Okay, but because we start with a sine, that's why it's r sine, and with sine, these symbols, the signs here have got to be consistent, right? So we've got a minus here. It's the same as same to reflect the fact there's a minus there. And if we go to our identity page again on page 4 in the formula booklet, okay, so last time I wrote x, didn't I? But this time it's this theta, right? So we theta here. So a becomes theta. So I'd have r here, square bracket. So I'd have sine then a, which of course is theta in this case, and then cos b, and b is alpha again, yeah. And then, of course, because there's a minus being chosen here, because this minus alpha, I'm choosing the bottom one, aren't I, in this compound angle formula here, the bottom one. Choose the bottom one here, I've got to choose the bottom one there, which is also a minus. And then cos a, which is theta, sine alpha. Okay, happy with that? So what I do then is I swap them around. If you remember, I swap these around, okay, and then I multiply out by r. Maybe I'll do this in one go now. So I'll do r, so cos alpha sine theta, okay, just swapping them around, minus r times it by r, and then I'll write sine alpha cos theta. Okay, and of course on this side I've got this, haven't I? What you'll notice quite nicely is the signs are consistent, aren't they? So we don't have to worry about the signs because they're the same. And when I compare, I've got r cos alpha here in front of the sine theta. I've got 21 here. So r cos alpha is equal to 21, equation 1. And r sine alpha in front of the cos theta is equal to 20. As I said, ignore the minus signs, don't worry about it, because, you know, if I did write minus r sine alpha, I did write minus r sine alpha, I'd say it's equal to minus 20. So then you'd have minus this side, minus that side, and they cancel. So there's no need to do it, right? They're consistent. So we can say, look, r sine alpha is equal to 20. Equation 2. So then, just like before, we do 2 divided by 1. Okay, so r sine alpha divided by r cos alpha will be 20 divided by 21. R's will cancel, so I get tan alpha equals to 20 divided by 21. So that implies then alpha will be tan to the minus 1 of 20 divided by 21. So we get, let's just do that, get an answer to be 43.6 degrees. Okay, so we've got our alpha. To get r, remember we can use Pythagoras, so we square each of these and add them. So like when you do Pythagoras theorem, you square the two smaller sides and add them. When I square that and square that, if you remember, that becomes r cos squared, that becomes r sine squared. Add them, you can factorize out the r squared, and you've got cos squared plus sine squared in that bracket. Cos squared plus sine squared is 1, so you're just left with r squared there, and that will equal to that squared plus that squared. So you're allowed to do this in the exam, right? You don't have to show all that work, and you can just show this and get to it straight away. Just appreciate you've got that squared here, r squared here. Just remember r squared is equal to that squared plus that squared. So if I get my calculator, 21 squared plus 20 squared is 841. And then that implies then square root of 841 is equal to 29. Okay. It's useful to do this approach because if you sub that back in there to get r, it might not come out exactly as we've got here. So that's important, right? So we say therefore 21 sine theta minus 20 cos theta is equal to 29 sine theta minus alpha, which is 43.6. Okay, so you've done that part there, you've expressed it in the form r sine theta minus alpha. It says then, part 2, use your results to part 1 to find the greatest value of this. Write down the value of theta for which this greatest value occurs. Now, if you notice on the bottom here, okay, you've got essentially this, haven't you, but plus 31. So we can say that's going to equal to 1 over, okay, put this side by side here, I can say that's going to equal, well, you've got this here, so I can write that as 29 sine theta minus 43.6, okay, because that's what that's equal to, isn't it? We've just established. Okay, so instead of writing this now, I can write the 29 blah blah blah. Plus then, of course, it says 31. Okay, now we want the greatest of this. We want the greatest of this. Okay, so to get the greatest of this, remember, to get the greatest fraction, we need to have the least on the bottom, yeah? So the greatest fraction means we need this bit is least. And the least of this occurs when sine is at its least, okay? So when sine is at its lowest, sine is equal to minus 1, isn't it? Because if you remember, sine is between minus 1 and 1. So this occurs when sine theta minus 43.6 is equal to minus 1. Okay, because that's when that will be at its lowest. Okay, when it will be equal to minus 1. Remember now, we need this to be at its lowest, yeah? Because dividing by the lowest will give you the greatest fraction. You know, if I want the greatest slice of cake, I need to divide by the least amount of people. So that lowest this will be when it's minus 1. So actually then we can work out what the lowest is. We can put what the greatest is of this, sorry. When the bottom's at its lowest, it will be 29 times sine theta blah blah blah, which is minus 1. When it's at its least, plus 31. So if I work that out, that'll be minus 29 plus 31, so it'll be 2 on the bottom, so it'll be 1/2. Okay, that's what the answer will actually be when this is equal to minus 1. So I need to do then theta minus 43.6 equals to sine to the minus 1 of 1. Okay, or minus 1, sorry. So the minus 1 there. So theta minus 43.6 is equal to, now when that's minus 1, that will be 270 degrees. Okay. So then you just got to take that 43.6 over and add, so you get 313.6 degrees.